Hello.
Listening, affirming my accomplishments.
Just gotta go here first.
Yes, thank you.
I did get the notes from somebody.
Did you do some two people? Maybe,
Yeah.
Here, I give you some notes. Oh, lovely. See what I'm always you can notes from two people. Make those problems that I put up
Sure, I got so much.
some of them are in text, and some are just worksheet or on the slides. In there.
I'm gonna hit you tomorrow.
Okay. Then you're. And I'll put,
Use it as an exercise.
yeah, and some more chapter pops off, because that will just. It'll help you. Dig up. Not. Is either.
Also have to.
Let me know on Google Classroom, you need it for problems, but they have to have them in homes. They don't. Dr. Darberry, are we still selling goggles?
We will and through September 11th.
You're in luck. So in Google Classroom, look at the very bottom of the screen. There's a lovely little guy that came from Dr. Darberry. This is when they're selling goggles and the location for those guys and how much they are. So you have till the 11th to get up here.
I have a question. We stand at the window, actual and, okay.
Sorry, Dr. Darberry.
That's exactly.
We're moving. We're moving. Sorry.
Sorry.
We should just, yeah. We can keep it the whole.
You're like me.
No, I'm just doing saying 9,000 years, it's a weekend, Kelly, suck it up. Get up. What is your problem?
I'm pathetic. This is what I feel like. I'm like, part of my soul feels like you really need a break. And this one's like, suck it up. What are you gonna do? It's a full break. I know. Hang on for the ride. Come on. Good luck today. Sorry to monopolize your time. All right, you guys okay? Yes. Otherwise, you'll get to hear something very loud. You're welcome. We'll get any questions. Oh my. And we're missing a bunch of people too.
Uh, one 862. 761. Hmm. Where was it? Would help if I did this now. Um, okay, our Mentimeter's up. These are the that's the number to get in. I'm ready for a 3-day weekend too. I need a nap too, but all's good. Sorry for the anxiety. Ouch, my leg hurting. Oh dear. Well, if anybody needs to come talk to me, we can always go chat afterwards. I'm sorry that people are having such a rough day. I'm around if you need me though. So I will leave it at that. We're gonna go ahead and get into the chemistry because unless you want to share on some of these, I figure you'd rather come talk to me if you need me. So in today's lecture and activity, what we're really discussing is the atoms of the elements. The atoms of the elements consist of 3 subatomic particles. Each subatomic particle has its own unique piece of information. And with those subatomic particles, we can actually discern which element we are talking about. So one of those subatomic particles is the particle of a proton. And so the first question is, what charge does a proton have? Okay, of the 18 people that have answered, which is most of the group, you are correct. The proton is the positively charged subatomic particle in an atom of an element. So where is that proton located? The proton is indeed located in the nucleus of the atom of the element. The nucleus itself is extremely small compared to the rest of the atom of the element. It would be like sticking a fountain pen with the tip up in the middle of a football field. That little bit of a fountain pen with the tip up represents the nucleus. The rest of it is the other portion of the atom of the element. So a question is, what's the responsibility of the protons in the atoms of the elements? What does the protons determine, in other words? Okay. So the protons determine the identity of the element. The protons determine the identity of the element. And they also are related to the atomic number as found on the periodic table. So if you look up here at the periodic table, these blue numbers in the top right-hand corner are known as the atomic number. That number is also equal to the number of protons. What that means is, let's say I have iron at E, which is atomic number 26. It means that iron has 26 protons. No matter where I go, iron will always have 26 protons. The number of protons can never, ever, never, ever, ever, ever change.
Because if you change the number of protons, you will change the identity of the element. Because if you go and say, oh, I have 25, well, now I've got manganese. So again, the number of the protons is responsible for the identity of the element, and it is equivalent to the atomic number, which is the blue number on the periodic table. Now, I
Stress the fact that the number of protons is a constant for a specific element. And that is, I did that for a reason. And the reason I did that is because a lot of you indicated that it had to do with the charge. But the protons never change. A positive charge does not mean we gained or lost any protons, because the protons can never ever change. It's the electrons, the loss and gain of electrons, that actually determine the charge. Well, you already answered that question. Did I miss one? Oh, I did miss one. So we made one way to measure the mass of a proton is using grams. But if you do so, you're talking about something that is a value in scientific notation that has a superscript of a -27, -29 type number. It's itty bitty 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 bitty. So instead of talking in terms of grams, we talk in terms of atomic mass units. So what is the atomic mass unit of a proton? Is it 0.0005? Is it 1.00727? Or is it 1.00867? The four of you that said 1.00727 are correct. A proton has an atomic mass unit, an AMU, of 1.00727. We did answer that question, so I'm going to skip. So let's talk about the next subatomic particle, which is the electron. And what charge does an electron have? An electron is a negatively charged subatomic particle. Where is the electron located? it is kind of a giveaway. The electron is located in the electron cloud. So when I gave you the example of the fountain pen in the middle of the football field, the fountain pen represented the nucleus. The rest of the football field represented the electron cloud. What is the atomic mass unit of an electron? Okay. The atomic mass unit of an electron is 0.0005 AMUs. Now, folks, that's interesting with respect to what I just told you about the size. So you have this little bitty pin that represents the protons, which have a mass of 1.00727. And you have this football field that represents the electrons. With their teeny mass. So in other words, that electron cloud does not contain much of the mass at all. It's almost entirely found in the nucleus, the atom of the element. What is the number of electrons equal to in a neutral atom? The answer is the protons. Protons are positive, electrons are negative. If we're going to reach neutral, that means there can't be any charge left over. So the number of positives has to equal the number of negatives. Which is also equal to the atomic number. Oops, I missed a question. Where did it go? Maybe I deleted it. Or I did something weird. Hold on. No, go back. Okay, for some reason I messed up on a question. Don't answer that one yet. The responsibility of an electron is that it is responsible for an element's reactivity. The charge is the result of the gain and loss of electrons. So again, the electron is responsible for the element's reactivity. So when francium goes boom in the presence of water to make francium hydroxide, it is francium's electron that gets lost on the way. When chlorine combines with sodium to make table salt, sodium chloride, chlorine gains an electron in that process. So electrons are responsible for an element's reactivity. It is the electron that can be gained or lost to make charges. Now we'll go on to the neutron. What charge does a neutron have? We're not very inventive. Neutral, neutron. Yes, a neutron has neutral charge, which means it has no charge. It doesn't have a charge at all. So where is a neutron located? The neutron is in the nucleus. You will find the neutrons and the protons in the nucleus. The only thing in the electron cloud are the electrons. So the electron cloud consists of the electrons. The nucleus consists of the other two subatomic particles. A neutron is neutral. It has no charge. So what does it do? It can't make a cation, it can't make an anion. What does it do? A neutron does help with the mass of the atom of the element, but that is not what it's responsible for. The number of neutrons in the nucleus determine the isotope of an element. The number of neutrons in a nucleus determine the isotope, isotope, of an element.
looking at this, it does feed into the mass of the atom, but it does not match the number of protons. It doesn't have anything to do with stabilization. It does not have anything really to do with binding energy, that is electrons. It doesn't have anything to do with balance. Its sole responsibility is to help with the mass and to determine the isotope.
So what is the atomic mass of a neutron? It's the one everybody's been wanting to hit today.
So yes, the atomic mass unit for a neutron is 1.00867. You will notice that the atomic mass of a proton, 1.00727, and the atomic mass of a neutron, 1.00867. These are the subatomic particles found in the nucleus of the atom. And they make up almost the entire weight of an atom. Because the electrons don't have much weight at all.
So one last question. How do you calculate the mass number of an atom of an element? It is the protons plus the neutrons is going to equal the mass number. Okay. So let's get into today. Let's look at how, besides understanding all those pieces and all of that terminology, let's just do a quick recap. Protons +1 charge. In the nucleus. They have a mass of 1.00767 AMUs. They determine the identity. Electrons have a -1 charge. They are found in the electron cloud. They have a mass of 0.00055 AMU. And they determine the reactivity. Finally, you have the neutrons. They have a 0 charge. They are also found in the nucleus of the atom of the element. They have a value of 1.00867, I think, AMU. And they determine the isotope. The number of protons is equal to the atomic number, which is found on the periodic table. The number of protons also equals the number of electrons for a neutral element. The mass number is equal to the number of protons plus the number of neutrons. And it is not found on the periodic table. So you may ask, well, how am I supposed to know it then? The fact is, mass number is, let me rephrase that. You will be given the mass number or the number of neutrons. You can't possibly know it. And much of this information can be found in an isotopic symbol. Now, there are really 3 isotopic symbols, but I'm only going to show you 2 because that's all I ever use with those particular 2. When I do an isotopic symbol, it could be anything. X is just representing any one of those up there. The mass number will be listed as a superscript to the left. That is one isotopic symbol. The other isotopic symbol I tend to use is the X dash mass number. Either one of these isotopic symbols is correct. Like I said, there's a third one, but it actually has some repetition in it, so I don't tend to use it. So in our last little bit, we're actually going to get into using these terms. So we are going to go with the element symbol. Let me actually do it slightly different. We're going to figure out the number of protons, the number of neutrons, the number of electrons, the mass number, the atomic number, and the isotopic symbol. This will be a lot like what you're going to see on an exam, folks, what I'm about to demonstrate. Let's just start out with something relatively straightforward. And I want to walk you through the thought process. So, for example, let's go with C13. What did I say the superscript represented? The mass number. So we know the mass number is going to be 13. Now, the rest of it, well, not the rest, but the next part we're going to get from the periodic table. So I gave you C, which is carbon, and I can look up and see that it has the atomic number 6. Now we know that the number of protons equals the atomic number. So that means that we know that we also have 6 protons. We know that the number of protons has to equal the number of electrons in a neutral atom of an element. So that means that it must also have 6 electrons. Now, to do the last one, you have to remember that your mass number has to equal the number of protons plus the number of neutrons. So 13 has to equal the number of protons plus the number of neutrons. And we know that the number of protons is equal to 6. So you can calculate the number of neutrons. So the number of neutrons comes out to be equal to 8. I'm at 7. I don't know what I'm thinking today. I was thinking the next one in line. 7. And then just to get the element symbol, it is just plain old C. For the mass number, that is where we would put it. Yes, always on the left. Because if it's a superscript on the right, that means charge. If it's a subscript on the left, that's technically where we would put an atomic number. So each location has a meaning. So yes, the mass number, if it's in a superscript, has to be on the left. Let's look at another way that this might be given to you. I could give you this. Again, I can't look out of these two pieces of information. The mass number is never where. It will never be found where? On the periodic table. So the mass number is not where I want to start. So I'm going to look at the electrons. And what do I know about electrons? They have to match the protons. So there's 17 protons. And what do I know about protons? They're the same as the atomic number, which is 17. So I go over here and I look for atomic number 17, and what is the symbol? Cl. So this is chlorine 37. Now I just need the neutrons. And how am I going to get those? What includes the neutrons that we've been working with? And let somebody else answer that hasn't had a chance. Mass or atomic? Mass number, right. So we go 37 is equal to the number of protons plus the number of neutrons, where we know the number of protons is 17. So that means our number of neutrons has to be equal to 20. Let me give you a couple to do real quick. Trying to remember some of mine. Now it's time to drink some water. Okay, how's it going? still see some people working, so let me give some time. Okay, what goes in the first square? We're gonna start with this square. Annie bought it. Chromium. What goes in the next one? 24, because why? That was its atomic number. What goes in the next one? 29, because you had to take 53 minus 24, which is equal to 29. What goes into the next one?
It's 29.
Very good. What goes in the next one? 24. And what do I put in the last? You put your symbol, and either you can do the mass number in one of the two ways above, so we can do it as 53. Yes,
So for the last one, we can do it either way.
yes. Okay, what about the next line? AG. What goes next? 47. What goes next? 47. What goes next? 109. And then 47. And finally, AG 109. I got to write in 47s and wanted to write another 47, but no. So what do you think? Doable? So how will you see this on an exam? I want to just mention that in the last minute. Number one, you will have a table like this that you will have to complete. Number two, I will ask you information a lot like the top one. Now, I won't ask you the numerical values. I don't ask you what the atomic mass is. So I'm not going to ask you the AMU. But the rest of that up there is definitely fair game. So just letting you know that it could be questions about that, or it could be questions about filling the table. So what we're going to do on Wednesday, because we got a holiday, is we are going to play the fish essentially with isotopes. So you got to be able to recognize the isotope so that you can get pairs and fours for Go Fish. Get you a lot more ready for that test. I will see you on Wednesday. And I'll head up to my office to take quizzes. As soon as I can shut the computer down.